So, hello guys. Today we're here to talk about the modulus function. So, modulus function. Now, just use the function notation fx, and this is also known as the absolute value function. And this is even though it's kind of weird, it's still the function though, and we write the modulus or the absolute value of anything as two straight line brackets. So the modulus of 25 would be 25. And let's say we have the modulus of negative 25. And this would still be 25. Let's say we have the modulus of negative pi. Modulus of negative pi is still pi. As you can see, the modulus of any real number is the magnitude or the scalar value of the number. And a modulus cannot have a negative value because it is always positive, because it indicates how much that thing is. And generally, what a modulus function looks like is the most basic modulus function is this y. We can use y for fx equals x. Well, this might look similar to y equals x graph, which is a linear graph, a straight line graph. But a modulus function is a bit different from a straight line graph, but it's really similar. So let's now try to draw the graph of the modulus function. And in order to draw it, we first have to make certain conditions of it. And the conditions are, let me use a different color. Let's use green. And that conditions are that the module of x is, okay, that was a bit ugly. The module of x behaves like y equals x function for values where x is more or equal to 0. However, if x becomes less than 0, the modulus function behaves a little differently. It behaves like a negative y equals negative x function for values which x is less than 0. And these are the conditions that result in the function of the modulus function. Fx equals here. So if you try to draw the graph, it says that for values more than 0, it behaves like y equals x. And so let's try to draw a graph. So if you draw the graph, I'll try to draw a very large graph though. This would be y, or the function value, and this would be x, or the x value. And so if you try to, we'll divide it, scale it, 2, 3, 4, 5, 6, 7. For these values, it's going to be -1, -2. The scaling could be off, but don't mind it. -3, -4. Okay, the scaling is way off now, but that's not the most important. But no, that was really off. -6 and -7. And for these values, it's going to be 1, 2, 3, 4, 5, and 6, and etc. It's going to be more. For the negative values, -1, minus 2. Oh. Minus 3. Minus 4 is keep getting larger. Don't mind it. Minus 5. I don't really have to write the minuses. So it says, so here's the origin of our graph, number 0. And it says for values where x is more or equal to 0, the function behaves as y equals x. So let's use the color, blue color. For when x is equal to 1, when x is equal to 1, then the absolute value would still be 1. So 1, 1 is over here, 2, 2 is over here, 3, 3 is over here, and etc. So if you draw the graph, use a ruler. I think that should do. For 4, 4 is 4. For 5, 5 is 5. And this will go infinitely. Now for when the value is x value is less than 0, so 0, minus 1. For minus 1, so let's say this is minus 1, x is still going to be 1, which means it's going to behave like the mirror function of y equals. As you can see on the right side, our function behaved like y equals x, while on the left side it's going to behave like a function of y equals minus x. So when x is equal to minus 1, it's still going to be 1. When x is equal to minus 2, it's going to be 2. When x is equal to minus 3, it's going to be 3. And let's draw this graph. Yeah, something like this. And this is a general function of the absolute value function.